doing, I promised you your diagrams, you have them. Also, what I want you to do with all the questions in the booklet, in fact, the questions on excretion, we have to answer that together. That is from a matric exam. I need you to get used to the types of questions you're going to be faced with in a few weeks' time. We're not going to say matric is next year, it's a few weeks' time. So what I want to do today is excretion, as promised, very, very important. And the last structure that we must do the adaptation of is the Malfidian body. Okay. So remember, in your exam, you could be asked, how is the alveolus structurally suited for its function? Or how is the alveolus an efficient gases exchange surface area? How is the villus an efficient absorptive surface area? And now the last one. How is the Malfidian body an efficient filtration area? Because that is the function of the Malfidian body. Pressure filtration, ultrafiltration. So, again, I promised you I will send you that diagram with the adaptation. So all I want you to do is try to answer and guess if you don't know the answer. But remember, we're not going to use the word it. Okay. The structure that I'm drawing, what is the structure called? Bowman's capsule. Bowman's capsule is with a capital letter because Bowman, he named it after himself. Okay, so that's the Bowman's capsule. Now, come, I don't see many of you focusing. Why are you nervous? I'm in front of the camera. They're just looking at your head, right? So, Bowman's capsule, cup-shaped, increases surface area for more filtration, for more substances to be filtered. Now, I just jumped to pressure filtration because I'm taking it for granted you know the structure, the diagram of the excretory system, you know the macroscopic structure. So let's quickly talk, let's revise. What is the definition for excretion? Let's just take a time out and let's discuss, revise. Excretion. Mandisa? Yes. The removal of metabolic waste from the body. Metabolic waste, metabolism comes from the word, it's metabolism. I'm nervous, sorry. Metabolism. All the chemical reactions that take place in your body, in your cells. And during these processes, there are wastes that are produced. And if these wastes stay in your cells, these wastes will toxify your body, will poison your cells. So that is what the excretory system does. Gets rid of the metabolic wastes. Can somebody name some of the wastes? Quickly. One that you're busy releasing right now. Okay. So it's not, the waste is actually water, excess water. Now listen, it's excess water. Your body is only going to remove the excess water. Use what it needs and only excess water is removed. Excess salts. What you're busy exhaling right now? Carbon dioxide. Right. And then, of course, urea and the uric acid. Now, you have to say for excretion, metabolic wastes. You have to say removal of metabolic waste. That word must be in your definition. Okay. Now, there are three parts of the functioning of the nephron. If you remember, the first one is pressure filtration or ultrafiltration. The second important function is tubular reabsorption. And the last one is tubular excretion. So what I'm doing is the role of the Malfidian body. And the Malfidian body is suited, has to be structurally suited for pressure filtration. I already did the first one, which is the Bowman's capsule. Cup-shaped to increase surface area, so more substances are filtered. That's what the kidney does. Blood flows to the kidney, and the kidney has to filter the blood. That means blood with good substances and bad substances flow to the kidney, and the kidney has to separate the good substances from the bad substances, the wastes. The wastes remain in the kidney, and the good substances that you need return back to the heart. So that's what filter means. And filtration is very, very important. Today I have a lot of lovely questions to ask you. And the only reward for you is no sweets, but I'll give you a clap. Okay. So, that is the Bowman's capsule. Now, when we're drawing the blood, the arterial, the afferent arteriole. I say it like how I'm going to pronounce it. Afferent. A comes first. A is the first letter in the alphabet. And the thinner one, efferent. Efferent, E for exiting. Now, the coil structure is the glomerulus. Yes, I know my label lines are not parallel. Together, the glomerulus and the Bowman's capsule makes up the Malfidian body. I told you yesterday, anything that's stacked or coiled or folded in life science, the function is for increasing surface area. What is the function of the Malfidian body, of the glomerulus? Filtration. The glomerulus is coiled to increase surface area, so more substances are filtered. Increase surface area for filtration. You can shorten it. Now, the afferent arteriole is wider in diameter compared to the efferent arteriole. Can anybody give me a reason why? Yes? Increase the pressure. So because of that, there's a pressure that builds up here. And that pressure is responsible for filtering the substances. So only the small substances will be allowed to enter the Bowman's capsule. The larger substances will not be allowed to enter, because they are very special cells that line the Bowman's capsule. Do you remember the names of these cells? Tiffany, you shaking your head? Has holes in them. That's not the name of it. Yeah. Somebody said? Podocytes. Good. Podocytes have slit pores, which is also very good for filtration. Between the pores, the substances that are small enough are allowed to be filtered. Now, also the glomerulus has a thin layer of cells with pores to also aid in filtration. You need a lot of things to help. All these structures have to be suited for filtration. Now, name some of the substances in the blood that will be found in the afferent arteriole. And I think there's so many of us here, each one can name. Water. We're going in order. Everybody will get a chance to answer. Don't worry. And if you want to turn around and wave at mommy, you can. It's mineral salts, right? A complete answer, mineral salts. Okay, I was going to write AA, but vitamins. You're getting excited because all the easy ones you guys are getting. Give everybody else a chance. You gave me 2 answers. Urea, uric acid, red blood cells. I'm just going to write RBC. Hormones. I'm trying to fit everything on one board. Take a guess. Your friends are not giving you the answers. You can say white blood cells, platelets, proteins. We can carry on. What else do we leave out? Glucose we left out. Yes, who's mamming me? Fats, 3 fatty acids and a glycerol. Now, all these substances are in the blood, flowing towards the glomerulus. And only the small substances will be allowed to enter this Bowman's capsule. When the substances enter the Bowman's capsule, the substances are called the filtrate. Right. What substances are small enough to enter the Bowman's capsule? Okay, I'm writing AA, right? Urea, uric acid. It's going to be glucose, water, vitamins, mineral salts. Now, all the other substances you will never find. Okay, not you will never find. Under normal conditions, if your kidneys are functioning normally, you will not find red blood cells, white blood cells, proteins. These substances are too big. If you have a kidney infection, then one of the structures that are affected is the Malfidian body, where these big substances obviously enter, and obviously we find it in the urine. So under normal conditions, you will not find red blood cells, white blood cells, and proteins. They are too big. And we need this pressure. We need the pressure from the glomerulus. But why is it? Okay, I'll ask you the question at the end when you forgot all your work. Right. So, all these substances now enter the Bowman's capsule and are the filtrate. Now that is pressure filtration. Now let's look at the structural suitability. Bowman's capsule, cup-shaped. Increase the surface area for filtration. Afferent arteriole is wider in diameter than the efferent arteriole, and that is what causes the pressure to build up and causes the substances to be filtered. Glomerulus is coiled, increases surface area for more filtration. The thin layer of podocytes or cells that line the Bowman's capsule, podocytes with slit pores, also aid in filtration. The glomerulus has a thin layer of cells with pores, also aids in filtration. And that, when you talk about the structure, you tell us how it helps with filtration. And then most of the time you will see single layer of cells that line the blood vessels, single layer of cells that line the Bowman's capsule. How does a single layer help with filtration? Not easy. Faster filtration. Rapid. Remember, rapid. You just throw that word back at me. If you have 20 layers, it's still going to be filtered. But one layer, faster filtration. Okay, so that is now the structural suitability of the Malfidian body. And I promise you don't have to write anything. Today, you will get that diagram. I will draw that for you, write the adaptations, and send it out for you. Okay, so that is a Malfidian body. That's very, very important. Most likely, most teachers will ask this. Okay, most teachers will ask this.